Open, calm, confident. What if I told you that in the 1960s a rocket-powered airplane, flown by a single pilot in a pressure suit, ripped away from a B-52, ignited a monstrous engine, and for a few terrifying minutes climbed and hurtled through the edge of space? Short pause. That aircraft was the North American X-15. Today I'll take you through its story. Why it was built, how it flew, the brutal numbers it reached, the people who flew it, and why it still matters. Let's go. Beat. If you enjoyed this video, make sure to hit the like button, JK Auto Review, share it with your friends, and subscribe. The X-15 wasn't a fighter or a bomber. It was a research rocket plane, a joint program between the U.S. Air Force and NASA designed to learn how vehicles behave at extreme speeds and altitudes. Think of it as a flying laboratory. Every flight returned data on heating, control in thin air, and re-entry dynamics, data that helped shape later spacecraft. Short pause. Simple flight picture, vivid. Here's how a typical mission played out. A modified B-52 carried the X-15 under its wing to high altitude. At the release point the rocket plane dropped free. The pilot pulled a few seconds of steady control, then lit the X-15's rocket engine. For a few minutes the craft burned like a controlled missile, accelerating to hypersonic speed and climbing toward the edge of space. When the engine cut off, the pilot was alone with momentum, a thin atmosphere, and a long glide back to a runway or dry lakebed. Pause. Specs. Crisp, on-screen bullets. Quick specs you can drop on screen. The X-15 measured about 49 feet long, with a stubby wingspan of roughly 22 feet. It had a single cockpit and one brave pilot. Its heart, the XLR-99 rocket engine, produced enormous thrust for short bursts, and the whole vehicle was designed to withstand extreme aerodynamic heating and stress. It was small, fast, and brutally unforgiving. Short beat. Records and numbers, dramatic. Now the numbers that make people stop and stare. The X-15 reached speeds well into the hypersonic regime, multiple flights topped Mach 6. A handful of missions pushed even beyond Mach 6.5, and the program's fastest flights were faster than 4,000 miles per hour. In altitude the X-15 didn't just scrape the sky, a few flights crossed the edge of space. Some missions exceeded altitudes of hundreds of thousands of feet, reaching above the commonly cited Kármán line, the 100-kilometer mark, which many consider the boundary of space. Pause. Pilots and heroes, human touch. This program wasn't built by machines alone. Test pilots like Joe Walker, William, Pete, Knight, Scott Crossfield, Neil Armstrong, yes, the same Neil Armstrong, and many others climbed into that tiny cockpit and pushed the envelope. These were highly skilled pilots and engineers who understood that every flight could teach the next generation of aerospace designers how to survive re-entry, how to control a vehicle in near-space conditions, and which materials and instruments would work in the worst-case environment. Gentle pause. How the data helped. Connecting dots. Why did the data matter? Because the X-15 filled a crucial gap between conventional airplanes and spacecraft. It gave engineers real flight data on hypersonic aerodynamics, control surface effectiveness in thin air, heat shielding performance, and pilot-vehicle interaction during re-entry. That isn't theoretical wind tunnel stuff, that's the real world under thermal and structural stress. The lessons from the X-15 informed designs and procedures for later programs, from early spacecraft re-entry profiles to the space shuttle and beyond. Short pause. The dangers, honest tone. Make no mistake, the program was dangerous. At hypersonic speeds even small mistakes or tiny structural issues could be fatal. Extreme heating, rapid changes in air density, and the limits of human reaction time meant every flight had real risk. Several missions ended poorly, and the program paid a human price. But the engineers and pilots accepted that cost in return for knowledge that couldn't be gained any other way. Somber pause. Notable flights, highlight reel. A few flights stand out. There were flights that focused purely on speed records, pushing the X-15 to maximum velocity to learn about shock interactions and heating. Other missions chased altitude, climbing higher and higher to study the transition from atmosphere to near space. In 1963, pilot Joe Walker made flights high enough that he crossed the Kármán line. And in 1967, William, Pete, Knight flew one of the fastest missions, setting a program speed record that still amazes aviation fans today. Short beat. Engineering detail, for the curious. On the engineering side, the X-15 used advanced materials for its time, special alloys and thermal protection measures to resist blistering and erosion from aerodynamic heating. Its control systems blended pilot input with stability augmentation to keep the plane flyable when the air was thin and control surfaces were losing bite. The cockpit itself was compact and instrument-heavy, a pilot's bubble of life support in an otherwise hostile environment. Pause. Incidents and lessons, measured. Where there were successes, there were also hard lessons. A few accidents revealed aerodynamic instabilities or limits of human tolerance. Each investigation tightened safety procedures, improved instrumentation, and refined emergency protocols. Those iterative improvements are part of the X-15's legacy. Even in failure, the program taught engineers what not to do next time. Short pause. Legacy, punchy and clear. So what's the takeaway? The X-15 was more than a record setter, it was a bridge. It helped bridge atmospheric flight and spaceflight, producing empirical data that shaped how vehicles re-entered the atmosphere, how instruments were designed to handle heat and pressure, and how pilots should be trained for extreme conditions. Its legacy lives on in modern hypersonic research, re-entry vehicle design, and our broader understanding of high-speed flight. Beat. Visual suggestion for creators. If you're making a video, show the contrasts: the tiny cockpit against the vast sky, the B-52 mothership with the X-15 underwing, heat-scorched test articles beside modern spacecraft. Overlay altitude versus speed graphs, and put a clear marker for the Kármán line so viewers can visually grasp how close these pilots got to space. Short pause. Conclusion: warm, invitational. The X-15 reminds us that progress in aerospace is often hands-on, small teams, daring test pilots, and flights that answer one question at a time. Without that work, many of the re-entry techniques and high-speed understandings we take for granted today might have been delayed, or discovered the hard way. Beat. Call to action: friendly. If you enjoyed this deep dive into the X-15, hit like and subscribe for more aviation history and experimental aircraft breakdowns. Tell me in the comments which aircraft or space program you want us to cover next: Bell X-1, X-43, or maybe the State Route 71. I'll pick one and do a full narrated review. Thanks for watching, fly safe, and keep looking up. Smile. If you enjoyed this video, make sure to hit the like button, JK Auto Review, share it with your friends, and subscribe.